Cool. So I am here to talk to you a little bit about USwitch's journey in data. I've called it from kind of chaos to clarity because I kind of want to emphasize that a few of these ideas are on a spectrum. There's no kind of distinct measure of chaos, or there's no distinct measure of clarity, but the idea is that you make small steps towards a better future. Before I start, my name is Sid, short for Siddharth. I'm the head of data at USwitch, and I do data engineering across RVU. And I'm here to talk specifically about USwitch. What is USwitch? USwitch it's a business where we transact users across multiple product lines. We help people switch their energy, their broadband, their SIMs, their mobile phones. We have a kind of tail of products that we offer people: home insurance, current accounts. We work with several other businesses. Confused.com is a sister company. TempCover is a sister company. If you've ever looked into temporary car insurance, that's a big thing now. But the idea is that we're very big in some of these markets, in energy, broadband, SIM. We do 30 million visitors a year. Eventually, it's like all of the country. Zoopla, very similar. They're sort of attached to us in some way as well. I was talking to someone and they said, how much data do you process? We process like roughly 700,000 events an hour, which is not, it's not the biggest thing you've ever seen, but it's a reasonable sort of amount of scale. But the idea is we want to help people to make confident decisions about their household utilities. Enough context. A little bit of framework for how we think about data at USwitch, and this is useful because it allows me to talk through some of the ideas we've kind of leaned on pretty hard. The first is we talk a lot about how we collect data. So this is where does our data actually come from? And broadly, it's three big things. It's the user or the browser. We have lots of databases that sit attached to services that we use, and lots of third-party sources like Acorn, audience data. You're probably familiar with these things. We analyze that data, so we stitch it into kind of a meaningful picture, because when data is disparate, the business can't really act on it. This is where most of our kind of transform lives. The lion's share of our transform right now is SQL, but in the past it's been Cascalog, for those of you familiar with functional data pipelines. And we activate that data. So the business operates on it, it makes decisions, we run experiments, we acquire different audiences, but we also make money from our data, right? Like we look like audiences, retention, cost of acquisition. These are important, meaningful things that data has a very significant role to play in. This is very abstract. This is a very kind of simplistic, reductive kind of box diagram of what things look like. So I tried to draw the browser as an iPhone because that's the average, right? So we collect data using what we call our event stream, or like a lot of RDS instances, or third parties, but it's a very long tail. That data lands in BigQuery, which is our kind of data warehouse of choice. Our transform layer exists in dbt. We use core, not cloud. And then we activate it. We synthesize kind of cool pictures in Tableau for our business to make good decisions with. We have a marketing platform that shoves data into various platforms that we use, where we acquire, transact, retain, that kind of thing. But you sort of get the picture of, like, we collect data, we analyze it, we activate it. This hasn't always been the case. This has evolved over many, many years. I've worked at USwitch since 2009, which is, I can't even do the math. I'm not going to go into like lots of like, in this year we did this, and this year we did this, but I've tried to distill kind of three different eras. And again, the aim here is to what have we learned through each kind of interesting piece, what has brought more clarity to the picture we're building. So again, that's the spectrum of things were very chaotic, but when we were in that era, it didn't feel chaotic, it felt good. And then things become clear over time, right? So in the early days, we collected some things. ROI on data was very low. Iteration was very slow. If you needed anything, you needed to talk to 3 PhDs. This was very real at USwitch. We had 3 PhDs on staff. To do anything with data, you had to talk to them. They were wonderful people. It was just very slow and expensive. It was very chaotic. And again, we weren't very efficient. Modern data stack was a thing. dbt was a thing. Fivetran was a thing. Segment was a thing. I'm sure you've all have heard of these vendors. A box diagram about like how to actually do this right was the thing. We did that. Things got really fast, but speed isn't always a good thing. And that's part of what I was trying to express, which is it was still very chaotic, which meant ROI on data was medium, because we did lots of things differently as opposed to some things well, if that makes sense. This is where we are today. We have this thing called an event stream. ROI on data is reasonably high. I'm sure it could be higher. But the kind of underlying principle is slow is smooth, smooth is fast. You don't have to be fast everywhere. It's actually more important to be deliberate. It's like a thing from riding motorcycles. I'm not actually into riding motorcycles. I just like the philosophy of riding motorcycles, which is quite strange. But yeah, this is sort of like an evolution of what some of these eras look like. Let's dig a little bit into collect, and I've talked some about event stream, and I want to dig into that a little bit. This is what that looks like. Again, very reductive architecture diagram, significantly more complicated than this, but you do the best you can. We looked at loads of options here, and the thing we liked the most about a lot of the options we looked at was explicit contracts, right? So the idea that you've got schemas, teams produce data, and they're held accountable to the data that they're producing, because that is part of a bigger picture. We've implemented the event collection ourselves, so we use Lambdas at Edge to do this. Our Edge provider is Fastly. I don't know if you've heard of Fastly, Cloudflare. They're all very similar. They all have Lambdas at Edge, and they're all blazing fast. We use those Lambdas to kind of land data into our warehouse. Then we've got loads of Spark jobs that run on that data that decides whether the data is valid or invalid, or if shape needs to change in some fundamental way. And then we have dbt that sits on top that does meaningful things. And this is sort of where that 700,000 an hour sort of comes from. The key thing here to take away is contracts, right? The key thing here to take away is contracts and the idea that not all data is equal. Some data is more critical to your org than others. So classification and schemas. Now that we've collected things, how do we stitch meaning into that? Like if you remember earlier, there were three kind of pieces of that frame. So again, more to the principle and the expression of a spectrum, we sort of have three broad layers. The kind of more fundamental layers, where the events land, what's valid, what's invalid. Iteration there is very low. Resilience is very high. SLOs are a very clear and tangible thing we push out of our platform teams. And again, the idea there is that teams shouldn't care about what's inside the box. That's more a platform problem. It's a self-service problem. We have a lot of tooling in that space, and how to define schemas, how to look at what's valid and invalid. And sort of as you come out of the shell, as things become a little bit more bespoke, you have the next layer, which is a bit more collaborative between platform teams and what we call product teams, where you define entities. So here as well, we've experimented with data vaults, star schemas, and what we landed on was that an entity-driven design has more sustainability in your org, because it's well understood by everyone, including technical, non-technical. The grain is consistent. Lots of really good ideas there. And then as you reach the outer shell, this is where the metrics live. This is where experimentation is very high, testing not so much, resilience not so much. But there's a bit of a microservice approach to this, which is instead of rewriting it, throw it away. Instead of redoing it, like just start again. And it's kind of scoped well enough that you could do that without incurring much debt. But again, please take away this idea that there's a spectrum of what's commodity and what's bespoke in that layer. Now that we've talked about collecting, how do we activate it? We use a platform. It's very cool. It's self-service. So the principle kind of behind a platform is that the scaling function has to be sublinear, i.e. you don't want to do more effort to see more value. It should be less over time. And resilience is high. I've not gone into a lot of depth about the building blocks of this because I didn't think that was interesting to this talk. Because there's so many vendors in this space. I thought the more interesting conversation to have in this space would be, how do you think about buying something? How do you think about like which bits should you build, if you should build it, how much of it should you build, etc. Little bit of crowd work here. Has anyone seen this picture before? This is the kind of decision-making model Amazon uses for a lot of their kind of big stuff. You can see some nods. So broadly, the idea here is that when you make decisions, there's two axes you want to consider them on, whether it's a consequential decision or inconsequential. Oddly, inconsequential is towards this side, whether something's reversible or whether it's irreversible. So the idea is if something is inconsequential and completely reversible, do whatever you want because it doesn't really matter and you can reverse it anyway. Versus you're baked in if you make that decision and it's very consequential to your org. Think about it, communicate. And like loads of big orgs, they've got specs on how to do these things. Like Google have this kind of architecture review spec that they do that we adopted. We saw a lot of value from it, but it doesn't work for everything. Like if you're just trying to ship a feature, do you really need to do that? Probably not. And again, this idea shouldn't be groundbreaking, but it's about that common expression of common sense, really. Shared expression of common sense is better when I said that. So I have one that's similar to that, but about how you buy stuff or build stuff, where you've got whether something is consequential on one axis and whether something is commodity or bespoke on the other axis. And again, the idea here is you want to be able to chart through this, right? Like not one answer, you don't have one answer for everything. So if something is very consequential, this is how you differentiate your product in a marketplace, and it's very commodity, you probably want to buy it. So for example, we're an e-commerce business. We're basically, a large portion of what we do is a website. So how we deliver that experience to a user is how we differentiate ourselves. If we're faster than Money Saving Expert or Money Supermarket and we're able to deliver a nicer, cleaner experience, people will marginally choose us more than the others. So our CDN, for example, is a great example of something that is critical to our business, but I'm not going to build a CDN. That's crazy. I'm totally going to buy it though. And I'm going to build a really thick layer around it. I'm going to invest in the interface around it. So like that could be something as infrastructure as code. I might Terraform all the VCL in my CDN. I might have a team responsible for it. But it's sort of that idea where you want to think about things in those axes. Similarly, if something is very commodity, but you don't really care about it, like you should still buy it, but maybe you just want to put a person in front of it. So for example, invoicing is something that is very commodity, but it's not how we're going to, like, money coming in is very important to our business, but like if it doesn't, I'll get on the phone with someone and that'll still happen. So we buy NetSuite and we have a NetSuite operator, but we don't have anything in NetSuite around like a thicker layer, if that makes sense. And if something is consequential but bespoke, this is like where you really start to get to the meat and bones of your business. You want to MVP, you want to iterate, you want to have sustainable teams. This is where a lot of the product thinking kind of comes into play. Versus if it's inconsequential and bespoke, you're probably just going to hack it together. And this is where you'll accumulate tech debt over time. This is the benefit of having worked in the same place since 2009. You write software and then 5 years later, someone's like, what does this do again? And you're like, I was kind of playing around with Golang for a bit, you know? But the point is, there is no future without that. You just want to be deliberate about those choices. So what do we do with our kind of activation piece at USwitch? We buy it. We work with a vendor called High Touch. They're great. They're really awesome, but we invest really heavily in a layer around it. So for example, their kind of audiencing platform piece, all our audiences exist as code before it gets in there. So they have a very crucial role in our ecosystem, but we're not beholden to them from that lock-in kind of perspective. So we've talked a little bit about that layer, but there's a dimension of that layer that you should think about investing in that I would like to recommend, that I want to talk about, which is how do you hold yourselves accountable to something that you've activated? Like you've done something meaningful for your business now. How do you hold yourself accountable to that? And I think monitoring is really the bridge between what you're responsible for and how you hold yourself accountable to that thing. If you're reliant on a business, you should think about monitoring it. And there's loads of really cool ways to think about this, right? You've got, like I was just chatting to Ramiz earlier about various methods you could use for anomaly detection. But what we've actually found is that a very simple approach to a very complicated problem sometimes has a lot of legs. So we use really basic kind of a very basic statistical methodology called control charts. So this is the idea that everything in the green zone is good, everything outside the green zone is probably an anomaly. I'm going to say that, but very thick probably. This is synthetic data. So if you're thinking we've had a traffic spike at 2 a.m, you're right. But yeah, part one is like how you actually look at these things. But the key kind of principle here again is you want to democratize it. You can't have one place where all of your monitoring lives. It has to be like, if your organization is diverse and you're doing multiple things, you want to be able to let people define their own kind of things that they care about. Because the overarching idea here again is, like if you have an infrastructure problem and you think, is it AWS? It takes you 30 seconds to answer that question. But tomorrow, if your conversion rate is up or down for that matter, or revenue per product is down, that isn't, at least for us, has been in the past a non-trivial question to answer. Why not have something that looks like your AWS or GitHub status page? If there are systems to describe the health of complex pieces, use those ideas. This is actually a tool Ramiz and I built together called August. And again, you could argue this falls afoul of the model we talked about earlier, because this is commodity and crucial. Maybe we should buy it, but invest in a layer. We haven't found anyone that does this well enough for us, so we just ended up building it ourselves. So we've talked a little bit about how we collect data, how we analyze data, how we activate data. We even talked about how we monitor the things and hold ourselves accountable to what we've activated. But how do we know all of these things are actually working? How do we know, at eSwitch, how do we know that these practices have a net positive? That the sum of these things are greater than the individual parts, I guess. Show of hands if you've heard of kind of DORA for DevOps. I love it. But just really briefly, there's this idea that successful companies do some things really well, which unsuccessful companies don't do them very well. And those things are lead time, change failure rate, time to restore failure, and time to detect failure. So we kind of proxy some of those ideas for data, which is lead time for analytics, time to restore failures in data, incident rates. Just really briefly, lead time is very hard to measure if you've tried it. So we use qualitative measures, not quantitative measures, and a lot of these things have resulted in things taking minutes and hours, not days. Incident rate is a really interesting one because we change the shape of our team depending on where the fire is the hottest. We actually send people into other teams because inter-team communication is hard and expensive. And time to restore is like you just need to be good at SQL, yes. So what should you take away from everything I've said? Because I've kind of given you a whistle-stop tour of a lot of ideas. The key thing is contracts. They're super crucial. They will elevate your quality to a whole other level. Navigate decision-making as not a black and white on whether you should build something or buy something, and invest in monitoring. It will, and monitor the outcome of a system, not the operation of it. That is a very key idea. So yeah, last thought I'll leave you with is you do not rise to the level of your goals. If you've heard this before from the systems thinking book, you fall to the level of your systems. As individuals, we will fail more than we succeed over a long enough period of time, but we will always be just as good as our best system or worst system, I guess. Yeah, that makes sense. Yeah, thank you. My name is Slator. I'm on LinkedIn. That's my email address. Reach out if you're interested in a job in data engineering. I know David is hiring for HomeTrack as well. So if you're interested, reach out to either of us. We'd be happy to talk to you. Thank you. Yeah, happy to do a Q&A if people have questions. If you put your hand up, I will get you the mic so that you can be heard on the recording. Sorry, I will come to you. That's it.
So how are you quantifying the ROI for the data?
Such a good question. In fact, the question. I think it really depends on context. So for example, context inside of a product team and context in your marketing team are completely different, right? So for example, a great way to quantify ROI and data for your product team is how many experiments are you running? How quickly can data power decisions that you make? Versus in marketing, ROI is a lot more tangible to a pound value. So it differs context by context, but it is 100% a measure you should be keen on measuring. I don't think there's like a good answer to that other than it depends. But use marketing, they're the best. They'll give you a pound figure. Yeah. At the back. This is good. It's a good system.
Thank you. Regarding how would you enforce data contracts, especially when you have external data sources and you have a system of event processing? Because if it breaks, then it's going to be a lot of time. And yeah.
This is a great question as well. So just to repeat the question, how do you incentivize the adherence to data contracts? So this is where I'm going to try this. Back is good. Yeah, back is good. This piece makes a lot of sense, which is the way that we work at eSwitch is if you have, as a product, if you're in broadband or you're at energy or in SIMO, and you want to buy some external data that may or may not meet a particular spec, You got to define that spec. And it comes back to you whether or not it's working or not working, because it's your P&L. So it's less about how I enforce the contract, more about the tools I can provide to the consumers to enforce their own contract, right? So this tool, for example, actually interfaces with Opsgenie, which the rest of our kind of technical org uses to manage incidents and downtime. So we're dovetailing off of the culture and practices that already exist in engineering in data for free. I like it. Any more? Go on. I'll give you the mic. Yep. Getting my steps in.
That was really helpful. I guess maybe just to add a bit more color around the architecture, can you take us through what you guys are sort of using for streaming, data movement, data storage, transformation engine, all that, maybe in a bit more detail?
Such a good question. Oh. I'll talk a little bit in depth with this diagram. So the fastly computed edge piece is VCL. We've had to actually invest in skill set, in tooling to write VCL. We've had to work with Fastly to actually write good Lambdas that work on the infrastructure, because we started using that product when it was a bit alpha, early release, which we do this with a lot of our vendors, where we'll buy something and then we'll go to them with a really interesting problem that they might help solve with us. And we see a lot of legs from that. So Google is another really great example of a vendor where we experiment with a lot of stuff with them. We don't spend a lot of money on Google, by the way. We like that kind of layer, the GBQ piece, for an org our size, the level at which we operate at, we don't spend that much money on actual hardware. We're very efficient. But we spend money farther down the chain when we buy ads from them. So they're a valuable partner kind of with us from that perspective. What that data, when it lands in GBQ, is just in SQL. We use just native BigQuery tables. We're not using Parquet or anything there to enforce any replays or anything, because those are not problems that have manifest for us. And again, a lot of this we learn into. Like we're not going for the big build just yet. We're seeing where the fires are first. And the most value we've seen from this is introducing contracts, introducing classification of events. So the idea that an event is either P0, 1, 2, 3, i.e. it's if this event starts failing, we're spending ads on things that aren't going to come back. That is a huge risk to our business. PySpark, so I'll talk a little bit in detail about that. We use, I forget Google Spark implementation, Dataproc, there you go, that's what it is. We use Dataproc. We experimented, so dbt Python has like a Dataproc engine. It didn't work for us. Again, a lot of this stuff was very early beta. We were working with Google on some of the libraries. We couldn't get traction fast enough. A lot of this was triggered with the fact that we were working with Segment and we wanted to walk away from them. So we were on a bit of timeline. So we chose to write the Spark ourselves. So PySpark is a really good toolkit for this kind of problem if you've not experimented with it before. And then we just very naively split that data up into whether it's valid or not valid, depending on the schema that it has been enforced again. The next iteration to what we want to do here is actually we want to pull that validation piece up to the Lambda, so that when you fire an event, you actually get the appropriate response code back as to whether or not that event was valid or not. Because right now you get a 200 OK for everything. And then you find out 30 minutes later when the monitoring is run that your events went valid, which again, actually materially has no consequence to our business, because as an iteration, it's so much better than what we had before. Versus, you find out as you're testing that the event is wrong or not. But yeah, that like in terms of how big a team we are and how we prioritize work, we're investing further down the chain in the activation piece just now, because as we unlock the scale of that, it's way more meaningful to our organization that we approach that systematically first. And yeah, we've been using dbt. We were very early adopters of dbt. We used dbt Cloud for a few years. We use dbt-core now. I will say from that piece, I think how you manage your DAG is not a solved problem. I think if you've been using dbt for like 2+ years, you have a very interesting problem that you should spend a lot of time thinking about. I have some answers in like closed beta that I'm not willing to talk about because they haven't worked. But if you're interested, so there's a Python library called Networks, which is used for topology planning, which I think has some very interesting legs in how you think about a DAG. Because I think you could, like, graph theory is a very kind of known, solved, and researched problem. I think it's a little bit sad that we don't use a lot of that computer science in the application here. But again, entity-driven design has had more legs for us than figuring out an automated way to manage a really complicated DAG with like 1,400 plus models. If that makes sense. I hope that answers your question, Hugo.